The U.S. Navy has signed a nearly $30 million deal with Coherent Aerospace and Defense, a California-based defense contractor, to develop an advanced laser weapon under the codename Songbell. This initiative focuses on pulsed fiber lasers with high-precision wavefront control, technologies at the core of next-gen directed energy systems designed to replace traditional missile defense mechanisms. The Songbell system aims to integrate 8 or more 50-kilowatt laser modules into a powerful 400-kilowatt class beam, using a beam-combining structure for increased lethality and precision. Beyond its destructive potential, Songbell is intended to support sensor illumination and long-range detection, offering a multipurpose edge for Navy vessels and possibly land platforms. Work on this project is expected to continue through early 2027, starting with a 20-month core contract and extending through optional 11 and 18-month phases. The Navy has already allocated over $12.8 million from its fiscal year 2024 research and development budget, funds that must be spent before the fiscal year concludes. The Songbell initiative is part of a broader shift toward energy-based weaponry, which military leadership increasingly sees as critical for handling the rising wave of drone and missile threats. The move follows operational challenges encountered during extended Navy deployments in contested areas like the Red Sea and Gulf of Aden. Since late 2023, American destroyers have intercepted over 90 incoming threats, ranging from unmanned aerial systems to anti-ship ballistic missiles. These defenses relied heavily on kinetic weapons like the Standard Missile series, some of which cost up to $4 million per launch. By April 2024, expenditures on these munitions had reportedly surpassed $1 billion. High-ranking officials including Admiral Christopher Grady and Rear Admiral Fred Pyle have warned that such costs are unsustainable. In contrast, laser-based systems like Songbell offer engagement costs as low as a few dollars per shot, relying solely on the ship's own power systems. As long as fuel is available to generate electricity, the weapon can fire indefinitely without requiring physical resupply. Coherent Aerospace and Defense is responsible for delivering the entire directed energy subsystem, including optical and beam control assemblies engineered for naval conditions. This marks a leap beyond the Navy's existing laser arsenal, which includes systems like the 30-kilowatt Laws and the 60-kilowatt Helios, now installed aboard the USS Preble. Unlike earlier generations, Songbell is being designed from the outset for full-spectrum operational use, from blinding reconnaissance drones to obliterating incoming projectiles. The Navy's push for directed energy weapons extends beyond Songbell. Current programs such as Odin, an anti-surveillance dazzler now fitted to several destroyers, and Helios, a scalable strike laser, form the foundation of a broader directed energy suite. The Hellcat initiative is also in progress, seeking to deploy a 300-kilowatt system to neutralize cruise missile threats. These efforts fall under the Navy Laser Family of Systems, NFLOS, an umbrella strategy for laser development and deployment. Technical challenges remain. Maritime environments complicate laser accuracy due to atmospheric turbulence, thermal blooming, and sea level distortions. Earlier laser platforms like Miracle produced extreme power but were rendered impractical due to chemical exhaust and safety issues. Today's designs, like Songbell, leverage fiber lasers that are electrically driven and far more manageable. They also enable precise modulation and sustained firing, but still face limitations when it comes to power availability and heat dissipation, particularly on legacy warships such as the Arleigh Burke-class destroyers. Looking forward, the Navy's future surface combatants are being built with increased electrical output in mind, specifically to host energy-intensive systems like Songbell. The strategic rationale is clear, with swarms of low-cost drones and missile barrages becoming the norm in modern warfare. Maintaining stockpiles of expensive interceptors is both economically and logistically infeasible. In high-volume engagements, lasers offer unlimited magazines and instant readiness. This U.S. focus mirrors a global trend. Nations like Israel are rolling out their Iron Beam system for drone defense by late 2025, while South Korea and Japan introduced smaller tactical lasers earlier this year. India is experimenting with systems up to 300 kilowatts, and Ukraine has deployed mobile battlefield lasers during its ongoing war. Russia and China continue to advance their own experimental platforms, including Peresvet and Silent Hunter. Not all laser systems are meant to destroy. Dazzlers like Odin and Israel's Light Blade are used to blind sensors or confuse targeting systems without inflicting permanent harm, making them compliant with international law, including the Protocol on Blinding Laser Weapons, as long as their effects are temporary. Devices such as the U.S. Phaser rifle exemplify this approach, delivering brief disorientation via dual wavelength bursts. While past programs such as the Airborne Laser or the Strategic Defense Initiative encountered cost overruns and feasibility issues, Songbell represents a focused, scalable evolution of those early visions. With technological maturity, mission-specific integration, and support from vertically integrated suppliers like Coherent Aerospace and Defense, the Navy appears closer than ever to realizing practical battlefield lasers that can defend against modern threats, at a fraction of the cost.